Today we're learning how to divide polynomials. There's two methods we're going to go over. One of them is called polynomial long division, and the other one is called polynomial synthetic division. So in either case, there's an algorithm, and the algorithm says that you have a dividend divided by a divisor, and when you perform long division on this, you end up with an answer. Your answer has to be written in the form of quotient, and I'll explain these terms further in a moment, plus the remainder, divided by the divisor. So this is the format we're looking for your final answer in, and it's very important that you understand how to write this because it will be part of, like, writing your answer in the correct format is part of the directions for this problem or for any long division problem. So if we scroll down in this box right here, you can see I just have an example done out for you, but I want to talk about the different parts. So this right here is your dividend, which originally will be the numerator of your fraction. This right here is called your divisor, which is the denominator. Here is your quotient, which you'll probably refer to as your answer. And your remainder is down here. Okay, so if you ever want to check your work, you can use this formula, which tells you you can write out divisor times quotient plus the remainder, and that's going to equal the dividend. Before I go through my first example, I want to just write out a basic long division problem. It's something that you probably haven't seen in a while, so it's good to review that with you. So if we had 479 divided by 7, you could rewrite this as 479 divided by 7. Your first term is the numerator of your fraction. Your second term is the denominator. These right here are the same exact problem, two different ways of writing it. So you can either use a division symbol or you can use a fraction. Besides from these two forms, you can write it in a long division format. In the long division format, your dividend goes underneath the sign, which I'm about to write. Dividend is 479, and your divisor goes outside of the sign. Here's your divisor, here's your dividend. And when you perform long division, you check. Let's take a look at the first term. Does 7 go into 4? No, it does not. Does 7 go into 47? Yes, it does. It goes into 47 6 times. 7 times 6 is 42. Subtract that number. 47 minus 42 leaves you with 5. Bring down the next number. You now have 59. Does 7 go into 59? It does not go into 59 evenly. It goes into 59 8 times. 7 times 8 is 56. Subtract this number. You're left with 3. So now, besides from having your divisor, which we wrote here, and your dividend, we just created what we call the quotient. And what we call the remainder. So based on the algorithm that I told you above, right here, quotient, your answer is written as quotient plus remainder over divisor. We would write our final answer as 68, that's our quotient, plus the remainder of 3 divided by the divisor of 7. And that's how you write your final answer. I know that's probably not how you wrote your final answer in the past, but this is how we have to write it for long division, for polynomial long division. Okay, so using this format, we need to go over a long division problem. We have 4x squared plus 23x minus 16 divided by x plus 5. So before you even start with long division, you have to make sure you have every term. And if you're missing a term, you need to add in a 0x term. So what I mean by that is you start in standard form. You have your exponent of 2. Next, you have to have your exponent of 1, and then an exponent of 0. If you're missing a term, you have to write in a placeholder. In this case, we are not. So we're going to write what we call our divisor outside of the division symbol, and what we call our dividend underneath the division symbol. This becomes x plus 5, and then we have 4x squared plus 23x minus 16. Okay, so follow closely as I go through this. I'm going to write out all my work on the side. You always start with the first term of your divisor and the first term of your dividend, and you need to divide those out. So I'm going to label this first because it's going to be the first term of our quotient. We have 4x squared divided by x. Again, 4x squared divided by x. First term divided by first term. So this should be a simple problem. You should be able to do it in your head, but I just write it off to the side so we can talk about what we're doing. If we eliminate common factors, we can eliminate one value of x in both the numerator and the denominator, leaving us with 4x. 4x is going to be the first term of your quotient. Now where you write it, you always line your exponents up. So notice right here you have 23x, that would be x with an exponent of 1. So I'm going to write 4x directly above that because that also has an exponent of 1. Once you do this, once you find this first term, you distribute and multiply that term, the first term of your quotient, by both terms in the divisor. So 4x times x, 4x times x gives us 4x squared, and 4x times 5 will give us 20x. I'm going to put parentheses around this expression because we are subtracting both terms. Right here, 4x squared minus 4x squared is 0. That's what we want to happen. And then 23x minus 20x, don't forget you're subtracting that term as well. So 23 minus 20x gives us 3x. You bring down your next term. Now we have a new first term of our dividend. We have 3x, so 3x divided by x is going to give us the second term of our quotient. 3x divided by x leaves us with 3. We do the same thing. 3 times x is 3x. 3 times 5 is 15. We are subtracting both of these terms. When we subtract 3x from 3x, that's going to be 0. Negative 16 minus 15 is negative 31. This number right here, this is your remainder. You don't have any other terms to bring down, so that's when you stop. This term right here, this is called your quotient. When we write our final answer, we write our answer as the quotient plus the remainder over the divisor. This would be 4x plus 3, that's your quotient, plus your remainder of negative 31 divided by the divisor of x plus 5. And this is your final answer. Number 2 looks a bit more difficult. We have 3x to the fourth minus 5x cubed plus 4x minus 6 divided by x squared minus 3x plus 5. So before we start, check your standard form. Exponent of 4, 3. We are missing our value of squared, x squared. Then we have our exponent of 1 and then 0. So I need to rewrite this. I'm going to rewrite this as 3x to the fourth minus 5x cubed. I have to add in a 0x squared plus 4x minus 6, and I'm dividing this by x squared minus 3x plus 5. So do not forget to do this. Okay, that's called a placeholder. You absolutely need it to make sure your answer comes out correct. If you don't do that, chances are you're going to end up subtracting incorrectly, subtracting the wrong exponents, which will lead to having a major mistake in your answer. All right, so labeling our terms, we have our divisor and we have our dividend. We write our divisor on the outside, x squared minus 3x plus 5. We write our dividend on the inside, 3x to the fourth minus 5x cubed plus 0x squared plus 4x minus 6. We do the same process we did before. Look at the first term and the first term. This is going to give us the first term of our quotient. We have 3x to the fourth divided by x squared. Eliminate your common terms, you have 3x squared. I'm going to line that up with my x squared term, and then I have to start the multiplying process. 3x squared times x squared is 3x to the fourth. 3x squared times negative 3x is negative 9x cubed. 3x squared times 5 is positive 15x squared. Once you find your values, you are subtracting every term, so put parentheses around that, and you are subtracting. To subtract, you have 3x to the fourth minus 3x to the fourth, which is 0. Negative 5x cubed minus negative 9x cubed is the same as adding 9x cubed, which is 4x cubed. 0x squared minus 15x squared is negative 15x squared. And you bring down your next term. The next term is positive 4x. We now have a new first term in our dividend, which is 4x cubed. And we're dividing that by x squared, which is the first term in our divisor. 4x cubed divided by x squared leaves us with 4x. That's the next term in our quotient. 4x times x squared is 4x cubed. 4x times negative 3x is negative 12x squared. 4x times 5 is 20x. We're subtracting every term. The first term, 4x cubed minus 4x cubed, is 0. Negative 15x squared minus negative 12x squared is the same as adding, so negative 3x squared. 4x minus 20x is negative 16x. Bring down your last term of negative 6. And we start our process again. Our new first term is negative 3x squared divided by x squared. Divide that out. Your last term of your quotient is negative 3. Multiply negative 3 times x squared, you end up with negative 3x squared. Negative 3 times negative 3x, positive 9x. Negative 3 times 5, negative 15. When you subtract these terms, your first terms will be 0, negative 3x minus x squared. Sorry, negative 3x squared minus negative 3x squared is 0. Negative 16x minus 9x is negative 25x. And negative 6 minus negative 15 is adding, and your solution is 9. We don't have any more terms to carry down, so this is called our, I'm writing the wrong thing. This is called our remainder. And up here, what we worked on finding is called our quotient. So we write our final answer as 3x squared plus 4x minus 3. That's the quotient plus the remainder of negative 25x plus 9 divided by the divisor of x squared minus 3x plus 5. All right, I provided a few extra examples already done out, and I also typed the steps with them. That way you could see exactly what I was doing. I think the more examples of these, the better. So you can check out these extra examples and you can try to do them by yourself. Make sure you end up with the same solution. But we also need to go over polynomial synthetic division. So synthetic division, it's going to seem confusing at first, but it ends up being a little bit faster. Now, here's the steps to synthetic division. I typed them out. I'm not going to read through that because I'm going to explain it as I do go through the problem. But you want to make sure you check back to that if you are struggling with what each step was. Okay, so please follow along closely as I go through these next two examples with synthetic division. You still have to make sure your function is in standard form. And that it includes every term. So I'm checking the first one. We have 2x cubed times plus x squared. We're missing our x term, x to the power of 1, and then we have our constant. So I need to rewrite this expression as 2x cubed plus x squared plus 0x plus 5 divided by x plus 3. All right, so this here is still called your divisor, and this is still called your dividend. It is still a division problem, so you still have those terms. But your synthetic divisor is found by setting your factor equal to 0. Also, synthetic division only works if you have a linear term, so something like this. And I'll explain that further when we get down on the problem a little bit more. All right, so to find our synthetic divisor, we're going to set x plus 3 equal to 0. X is equal to negative 3. All right, so once we have our synthetic divisor, that's what we just found, x equals negative 3. You then need to identify all of the coefficients of your dividend. So the coefficients are 2. This right here would have a coefficient of 1. We have a coefficient of 0 and 5. So the reason why I just highlighted all of those is because we're going to set up our synthetic division problem. And I'm going to write off to the side, I usually draw this little like box around it, my synthetic divisor of -3. Then I bring down every coefficient. So I bring down the coefficient of 2, of 1, 0, and 5. All right, leave yourself some space and draw a line. All right, you always add inside of the line and you multiply outside. Start by bringing down this factor of 2. We're multiplying 2 times -3. 2 times -3 gives us -6, and you write it here. So we just multiplied. Then you add inside. 1 plus -6 gives you -5. -5 times -3 gives you positive 15. We just multiplied. 0 plus 15 gives you 15. -3 times 15 gives you -45. And 5 plus -45 is -40. So this last number, whatever the last number is always going to be your remainder, every time. Oops. And these numbers right here are your coefficients. They're the coefficients working backwards from the constant. So just like we pulled the coefficients down from here, you're going to do the same thing for your answer. So I'm going to highlight these as I write them out. This is going to be your constant term. So we're going to write our constant as 15. After your constant term is your x value with an exponent of 1. So we have -5 times x. And then next we would have our squared value. So this is going to be 2x squared. All right, check your coefficients. 2, -5, and 15. The same ones that we have right there. You always start with your constant value. You'd have your constant, your value of x, your value of x squared. All right, when we write our final answer, we write our quotient, which is what we just found. This here, quotient. Final answer is quotient of 2x squared minus 5x plus 15 plus your remainder of -40 divided by your original divisor. Your original divisor is up here. It is x plus 3. Okay, these problems seem like they're crazy and probably difficult at first, but synthetic division is actually much faster than long division. The only thing is that synthetic division only works when you end up with a remainder of a constant number, so meaning a remainder with no variable. In order for that to happen, you can only have a synthetic divisor that is a single value of x plus or minus a number, so meaning a linear term. So synthetic division is restricted to divisors that look like this. And if we look at number 2, we have x minus 4. So basically, you can only use synthetic division if your divisor is x plus or minus a number. All right, let's go through number 2 a little bit faster so you can see that this process actually is quicker than long division. First, we're checking for standard form. We have 3, 2, 1, 0. We're good with standard form. Next, we're finding our synthetic divisor. Currently, we have x minus 4. Set this equal to 0. We get x equals positive 4. There's your synthetic divisor. Recall that your synthetic divisor is going to go outside of the little symbol or the little box that we make. I could just put a box around it. Let's do that. Then you bring down your coefficients. So we have a coefficient of 1, negative 6, positive 5, 12. 1, negative 6, 5, 12. Don't forget to bring your signs with each term, so if it's a positive or a negative. Bring down the 1. We add inside, we multiply outside. We have 1 times 4. 1 times 4 is 4. Add negative 6 plus 4. Negative 6 plus 4 is negative 2. Multiply 4 times negative 2. That gives you negative 8. 5 plus negative 8, that's a negative 3. Negative 3 times 4, that's negative 12. 12 plus negative 12 is 0. Here's your remainder. And these are your coefficients. So remember, you have your constant term, you have your x term, you have your x squared term. So I'm going to write my quotient as 1 times x squared, which we don't need that value of 1, minus 2x minus 3. Our remainder would be plus 0 over the divisor of x minus 4. Of course, if your remainder is 0, you in fact do not need to write it. So your final answer is just your quotient. All right, I provided you with some extra examples here as well. I taped out all the steps. I tried to draw arrows and whatnot so you can see what you're doing and your final answer is typed out. So it'd be helpful if you look over these, make sure you get the same answer as what I have typed. In the on your own section, you're allowed to pick if you want to use synthetic division or if you want to use long division. You can do whichever one you feel the most comfortable with. However, number 4, you have to use long division. The reason why is because of this divisor. So you can only use synthetic division if it's x plus or minus a number. This right here is x squared, so that does not work. So long division is your only option for number 4. Okay, these answers for the on your own section are posted on my website under the note sheet if you'd like to take a look at them. I also provided some extra videos in this section. So I've attached a video that I include for my pre-calc class, but it's actually just a review of these 2 topics. So it's the same type of note sheet, but different examples. That could be helpful. And I've also included a different video that's not me talking, so that could be helpful as well. All right, please let me know if you have any questions, and that's it for today.